Hi guys, concentration is a concept that comes up when we talk about solubility. So there's some vocabulary that has to do with concentration, and there's also some calculating that you have to be able to do. Basically, the concentration of something is how much solute is crammed into the solvent. So remember, a solute is something that's being dissolved, and a solvent is doing the dissolving. So we've seen different concentrations of copper sulfate solution. You've seen it be a really dark blue or be a less dark blue, depending on how much copper sulfate is actually dissolved in your water. And just in everyday language, you might see these terms: dilute, which means not very concentrated, or concentrated is also another way. So this one's very concentrated, we would say. Very concentrated. And this one over here, dilute, means not very concentrated. But those are just kind of everyday terms that you can use to compare one concentration to another. However, you can get way more specific than that. You can actually tell exactly how many grams of solute there are dissolved in how many milliliters of solvent. So the formula for concentration is the mass of your solute divided by the volume of your solvent. And what's interesting about that is that concentration is really the same formula as density, because concentration is like the density of a solution. It's how much mass is crammed into a certain amount of space. The difference between concentration and density is that when you're finding the density of, say, a piece of metal, you want the mass of the metal and the volume of the metal. But when you find the concentration of a solution, you want the mass of one thing, your solute, and the volume of another thing, your solvent. So you can calculate concentration in a couple of different types of units. You can do grams per milliliter, which are the same units that we use for density. So you can just figure out how many grams dissolve in each milliliter of solvent, how many grams of solute dissolve in each milliliter of solvent. Or sometimes you want to do it grams, how many grams dissolve out of 100 milliliters of solvent, and that's more convenient because usually you're not dissolving stuff in 1 milliliter of water. So it's usually better to know how many grams would dissolve in 100 milliliters of water because that's a more realistic use of concentration. I think it's useful when we're talking about the difference between a concentrated solution and a dilute one to think about what the particles look like. So you see these little blow-ups of the particles in the copper sulfate. You can see that in the concentrated solution, you've got solute particles that are dark blue, and you have solvent particles that are sort of purple. And the solvent would be water, so the purple would be like your water, and the blue would be your copper sulfate. So in a concentrated solution, there's a lot of blue particles mixed in with relatively few purple particles. And that's what makes it concentrated, and that's what gives it that nice dark color. And it doesn't really look like it in this picture, but this is a homogeneous mixture. Homogeneous meaning that the particles of solute are evenly distributed. Now, because particles are moving all the time, they're never going to look perfectly mixed, right? And all solutions are homogeneous. By definition, if you are a solution, if one thing dissolved in another, that means the particles are attracted to each other, and that means there'll be an even distribution of the solute through the solvent, which is how you get that sense that the mixture is the same throughout, which is where the prefix homo comes from. It means the same. So if something's homogeneous, it's the same throughout. So in the dilute mixture, you have fewer copper sulfate particles in the water. And that's what makes it have a lighter color and a lower concentration. Instead of just using dilute and concentrated, though, you can use these three terms to talk about how concentrated something is. You can have an unsaturated solution, in which case, if it's unsaturated, that means that more solute can dissolve in that liquid. It could hold more. It's not holding its max. If it's saturated, that means that you could keep adding more stuff to it, but it's just going to sit on the bottom as precipitate down here because it can't hold any more of the solute. And then under rare conditions, sometimes you can actually force a liquid to hold more solute than it's supposed to be able to hold, but it's very precarious, it's very unstable. And so the second that you give it the least little bit of a shake or somebody sneezes, or the container cools a little bit, all the stuff will crystallize out. This is what we did with our potassium nitrate when we did fractional crystallization. We used hot liquid to dissolve our potassium nitrate, and at high temperatures, lots of potassium nitrate dissolves. And that potassium nitrate stayed dissolved until we got it down to a temperature where it couldn't stay dissolved anymore. And in some cases, you found that even after it cooled down to room temperature, it still held onto those crystals. They wouldn't fall out of solution. So we had to give them more encouragement and put them in my refrigerator to make them fall out. That's called a supersaturated solution. It's holding more stuff in the actual solution than it's supposed to be able to. The terms supersaturated, saturated, and unsaturated are often used in solubility curve questions on tests and quizzes that I give. And here's how I might ask a question about this. I would say, if 300 grams of KNO3 are dissolved in 100 milliliters of water, so we'll write this down. So if I have 300 grams of KNO3 in 100 milliliters of water, and the temperature is, we'll say, 20 degrees Celsius, is this solution saturated, supersaturated, or unsaturated? Well, to answer this question, here's what you have to do. You have to go to 20 degrees, which is here, and figure out how many grams should be able to dissolve at that temperature. It looks like 25 grams. So at 20 degrees, 25 grams of KNO3 can dissolve, but look, I've got 300 grams dissolved. Clearly, that is supersaturated. It's holding more than it's supposed to be able to hold, and that is what makes it super saturated. It's not supposed to be able to hold that much. If, however, I had said to you it was holding 20 grams at 20 degrees, you would say it's unsaturated. Because it can hold 25, it could actually take 5 more grams. And if it was exactly 25 grams, then you would say it's saturated. Now, there's a difference between supersaturated and precipitate. Let me show you what I mean. All right, so these two pictures show you how you can know whether or not a solution that you've prepared is or is not saturated. Is it maxed out? Here's how you can tell. You add enough, let's say, salt to your water that you get a complete clear solution. Everything seems to have dissolved. And at this point, we're not sure if we're saturated or not until we add a little more. So let's say we add another 10 grams. Now we've got 40 grams in there, and we notice that we have some precipitate sitting on the bottom. If we've stirred and given it time, that would mean that that stuff sitting on the bottom cannot dissolve. So if we measure how many grams are sitting on the bottom and compare that to how many we added, then we'll know that we're holding 36 grams of NaCl in 100 milliliters of water, and we are saturated. So a saturated solution, you can't tell you have one in the lab until you see precipitate at the bottom. That's how you know, and you only know that it is saturated if you have done everything you can to make it dissolve. Now, sometimes students think, oh, well, heat it up and it'll dissolve, and that's probably true, although sodium chloride does not change its solubility that much with temperature. But with most substances, that's true. You heat it up and it will dissolve. But remember, we're talking about the concentration of this solution at a particular temperature, at say 20 degrees Celsius. At 30 degrees Celsius or 40 degrees Celsius, that solubility is going to change. And that's why we create solubility curves for substances, because it's not something that's the same at every temperature. You have to keep that in the back of your mind. Okay, to sum up, let's just go through some of the vocabulary that came up. So how would you define the term concentration? Well, I define it kind of like this. Concentration is the grams of solute dissolved in a certain amount of solvent. That amount can be anything you want. Any amount of solute means any amount of solvent. Typically, we ask for concentration to be in units of either grams per milliliter or grams per 100 milliliters. And here's how you can calculate concentration. Let's say I'm told that I have 36 grams of solute in 72 milliliters of solvent rather. If I want to know the concentration in grams per milliliter, I have to set up a proportion. I know that I've got 36 grams dissolved in 72 milliliters, and I want to know how many grams of that would dissolve in 1 milliliter. Now I cross multiply. When I do that, I'm going to get 36, going this way, 1 times 36, equals 72x. So I'm going to divide both sides by 72 to get rid of it. And 36 divided by 72 is actually 0.5. So 0.5 grams per milliliter. I could do the exact same thing if I wanted to know how many grams dissolve out of 100. The difference would be, instead of 1 milliliter on the bottom here, I'd write 100 milliliters. Then when I cross multiply, instead of getting 36 over 72, I'm going to get 3600 equals 72x. Divide both sides by 72, and now instead of 0.5, I'm going to get 50. And so, for out of 100 milliliters, I would say I have 50 grams per 100 milliliters is my concentration there. So you have to be able to do this for any problem that I give you like this. I'll give you the grams of solute and the milliliters of solvent, and you'll have to set up a proportion like this. Okay, so what does saturated mean? Well, saturated means that you're holding the maximum amount of solute that you can at that temperature. And unsaturated then means the solution can hold more solute. Supersaturated means the solution's holding more solute than it should be able to hold. Dilute just means that you have a low concentration. And a low concentration is due to the fact that you don't have that much solute dissolved. Precipitate, we've come up with this word many times. A precipitate is any undissolved solute that sits at the bottom. And there you have it. You could take a screenshot and you've got some definitions to help you study for your test. See you guys in class.